For decades, astronomers have observed one of the brightest and most enigmatic stars in the night sky, Betelgeuse, a red supergiant teetering on the brink of collapse. They predicted it would happen, but they didn't know when. Now, the James Webb Space Telescope has captured a moment no one thought we'd ever see. The initial stages of Betelgeuse's explosion. This is not just another deep space observation, it's a once-in-a-lifetime event, the closest supernova ever recorded by humans. Betelgeuse, nestled in the shoulder of the Orion constellation, is no ordinary star. It's a red supergiant over 700 times the size of our Sun and around 20 times as massive. For years, scientists have known it to be unstable, constantly swelling, dimming, and erupting. In 2019, it suddenly faded, sparking global speculation about its final moments. Now, with the precision of the James Webb Telescope, the mystery deepens. For the first time, we're witnessing real-time indicators of a star's collapse. We see massive energy discharges, shifting surface convection, and magnetic fields twisting into chaos. Betelgeuse isn't just dying, it's transforming before our eyes. The James Webb Telescope has been focused on Betelgeuse for months, using its infrared vision to peer into layers invisible to any previous observatory. And now, the data is in. What it shows is breathtaking. We can see convective bubbles the size of Jupiter bursting on the surface. We can trace plumes of hot gas streaming into space at unimaginable speed. And hidden within the light spectrum, a signature shockwave moving through the star's outer layers. For the first time ever, astronomers are observing the actual physics of a star tearing itself apart. This isn't a simulation, it's the real-time anatomy of a supernova. And it's happening just 642 light-years from Earth. Unlike other supernovae that occur in far-off galaxies, Betelgeuse's explosion will eventually be so bright it could be visible during the day, brighter than the full moon. But more importantly, its proximity gives scientists a once-in-a-generation opportunity to study the death of a star up close. How its core collapses. How elements like carbon and oxygen are forged. How the shockwave reshapes the surrounding space. What the James Webb Telescope has captured isn't just a star dying. It's the very process that creates the ingredients for life. The same elements that formed Earth and us. We're watching our cosmic ancestry in reverse. This isn't just science. It's revelation. A moment where humanity looked into the abyss of time and saw the light explode back. The explosion of Betelgeuse is not a singular event. It sends shockwaves across light years, disturbing the surrounding interstellar medium. Already, the James Webb Telescope has detected the early ripples. High-energy particles moving outward, heating surrounding gas clouds and altering the shape of the star's dust halo. But there's something else. A gravitational shift. Even from 642 light-years away, the collapse of Betelgeuse's core may have sent out gravitational waves, the kind we've only just begun to detect. If confirmed, this would mark the first time we've linked a visible supernova with direct gravitational data. And that would rewrite everything we know about the interaction between light, matter, and space-time. As Betelgeuse collapses, one of the greatest cosmic questions re-emerges: what's left behind? A neutron star, a black hole, or something stranger? The data from the James Webb Telescope suggests that Betelgeuse's collapse may not be entirely uniform. There are magnetic field disruptions, plasma voids, and a possible asymmetric fallback where material doesn't escape into space but is drawn back inward. Some astrophysicists are even speculating about a transitional object, a phenomenon that sits between a neutron star and black hole, theorized but never observed. If the James Webb Telescope has caught this in action, it would be the first direct evidence of a new class of cosmic object. With a star exploding just 642 light-years away, many have asked, are we in danger? The short answer is no. Betelgeuse isn't close enough to harm Earth, but the longer answer is more complex. The explosion will release a wave of high-energy particles, gamma radiation, and expanding electromagnetic bursts. These could potentially disrupt cosmic dust clouds, influence other star systems, and even trigger changes in how light from other regions reaches us. For now, the James Webb Telescope is closely monitoring the velocity and spread of this radiation front, because even if we're safe, the explosion may alter the optical structure of our galactic neighborhood, changing how we observe the universe from here on out. Betelgeuse is massive, ancient, powerful, and yet it's dying. A reminder that even stars, those eternal lights in our sky, have limits. What the James Webb Telescope has captured isn't just the death of a star. It's a cosmic mirror held up to us. Everything that lives ends. But in that end, new elements are born. New stars will rise from Betelgeuse's ashes. New worlds may form in the chaos it leaves behind. This is not destruction, this is cosmic renewal, and we were lucky enough to witness it.